Hi, everyone. Thank you so much for joining the NASA SBIR Ignite Ask Me Anything session. This is our last session. I'm really excited for the discussions that are about to happen. We have a really packed day today with 4 different topics that we'll be going over. We're going to give 2 minutes for more folks to funnel in. So yeah, we'll break for 2 minutes and then we'll come back. Thanks for joining us. In the meantime, if you want to, in the chat, let us know who you are and where you're from, that'd be great. Thank you. Okay, thank you so much, folks. Again, welcome to the last session of the Ask Me Anything sessions for NASA SBIR Ignite. My name is Donna. I'm supporting the SBIR Ignite program. I'm really excited to have you all here. Just to give you a little context of our structure for today's AMA, we're going to have Haley talk about the SBIR Ignite program, and then we're going to have the NASA subject matter experts talk more about the different topics. So today's topics are going to be cryogenic valves, microgravity simulators, lunar surface payloads, and radioisotope power systems. The rest of the time will be left for Q&A, and that will be the session for today. So with that, I'm going to hand it over to Haley.
Thanks, Donna, and thanks everybody for joining. We're really excited to talk through these 4 topics today. I am Haley Dowd. I am leading the solicitation development for the Ignite Pilot Initiative this year. And I'm going to quickly go over some general information about the pilot so that you'll have some background and understanding of what it's all about. But I don't want to take too much time away from the technical discussion. So I'm going to hit some high points and then we'll move on to those topics, which I know is what y'all are really here for. So next slide, Donna. So what is the pilot initiative and how is it different from our mainline SBIR solicitation? So SBIR Ignite is really looking to support companies that are product driven and that are looking at customers outside of NASA. So typically with SBIRs, NASA is one of the big customers for a company, but we're interested in funding groups that are looking outside of NASA and potentially like outside of space as a landing place for their product or technology that they're developing. It is similar to a traditional SBIR in that it follows the same phases that a traditional SBIR would follow, but we do have a little bit different proposal submission and selection process. So we are expecting to have the phase 1 solicitation for 2024 open in early summer. So we're looking at a June timeframe. And just as a little bit of background on how these have been awarded in the past, this program was started in 2022 as a 3-year pilot, and we've had 12 companies in the 2022 cycle get funded. All of those companies were also selected for phase 2 awards when they were up for phase 2 awarding in 2023. And then last year for the 2023 phase 1 cycle, we had 10 companies that were selected for award. Next slide. So what does this look like? How does this work for Ignite? If you're familiar with NASA SBIR, you've seen a very similar chart to this previously. So SBIR Ignite is very similar to Mainline in terms of the phases that it follows. There are a few key differences though. For phase one, you have available to you that same $150,000 over a 6-month period performance. You have the opportunity to apply for I-Corps and TABA. In phase two, during your prototype development, you would get $850,000. It's a little bit different for the period of performance here. You are able to apply for a 24-month period of performance, but we do suggest a shorter period of performance so you can get your product into market as soon as possible. And then, like traditional SBIR, you have phase 3 opportunities as well and multiple post-phase 2 opportunities. Ignite is a little bit different in the way that the process runs for proposal and selection. There's significantly more engagement due to the smaller cohort size. So as you can see through like these AMAs and other activities that you may have joined prior to solicitation release, we do a lot more community building. And then once the awardees are selected, we continue to maintain that level of communication through coaching activities, Slack channel. So we really are trying to build up the networks of our small businesses that we're working with so they'll be successful. We also have a fewer number of topics because we have a lower number of awards for this pilot. And those are completely separate from the SBIR and STTR mainline solicitation. So it has its own unique topics. And the solicitation is less prescriptive, meaning that we have the opportunity for our firms to maintain their go-to-market strategies. We have our proposal submission is a little bit less time intensive for our firms. And the topics that are put out are a little more open-ended so that you can provide your solution as you've been developing it. The other difference is an accelerated schedule. So phase 2 proposal period is actually a little bit earlier than mainline. So the goal there is to get you your funding as quickly as possible. So phase 2 proposals are due in the 4th month of your period performance of your phase 1. Next slide. Oh, if you may see on your screen right now a welcome poll, so feel free to fill that out so we understand who's joining us. We can learn a little bit more about you. So on this slide, you can see our SBIR Ignite topics from the last 2 years. In 2023, we had 5 topics, and in 2022, we had 6 topics. There are some similarities between years, including topics that related to hybrid electric aircraft, climate-focused technologies, ADR and orbital debris tracking, and some recycling activities. In 2023, we also had a really interesting topic on wildfires and mining and mineral processing for lunar and Earth-based applications. Next slide. So one of the things that makes Ignite unique is we have catalyst events. If you haven't been involved in one of these before, you should look into being involved in one in the future. This is a great opportunity. These are events that are held either virtually or as a hybrid event, which is co-located with a related conference. And at these events, firms are grouped with an expert panel that has experts from NASA, investors, industry partners that may be interested in similar types of technologies that you're working on. And it gives you an opportunity to talk to them and learn about their areas of interest, what they see as the future in that area. And it gives you a time to talk about your technology and get feedback. So to be involved in these programs, there is a call for applications in advance of the event, so you can apply to those. Right now, we don't have any applications open as we're preparing for an event on May 6th. You are still welcome to join that event if you are interested. It has a couple of different activities that are more open, so you don't have to apply through the application process. So definitely consider being involved in one of these Catalyst events in the future. Next slide. Like I mentioned, we have one coming up on May 6th. It will be focused on aviation batteries and is located in Chicago. So this event will be a hybrid event. There is the opportunity to join virtually, and you can join the general knowledge sessions by registering at the link below or going to the SBIR Ignite website and learning about those. It looks like they just dropped the link in the chat as well to make it easier for you. So you do still have the opportunity to register for this if you want to join for those general sessions. So do consider doing that. Or if you're in the Chicago area, consider joining in person. Next slide. So like I mentioned before, we do have a large engagement activity focus for Ignite. So there are lots of ways for you to get involved. One is through signing up through the general NASA SBIR STTR newsletter. So you can hear about when solicitations open and what we see coming on the horizon. You can also watch recordings for our previous topics during the AMA period. Those are all also located on the SBIR Ignite webpage. In addition, H4X Labs hosts a bunch of community building activities. So if you want more information about those, you can reach out directly and join the Slack channel to learn more and communicate with that team as well as other firms that are interested in Ignite. And then if you just have general questions about the SBIR program at a national level, you can investigate the Small Business Administration's website at sbir.gov. I think that should be my last slide. So I want to open it up for everybody. We can get started with the topic descriptions. And so just for awareness, we have not selected the topics for the 2024 solicitation. So these are just areas of interest that we have been investigating for inclusion in the solicitation. So this is an opportunity for you to learn about what NASA experts are interested in this area and ask questions that you may have related to those. So thank you so much for letting me speak to you. Donna, you want to take it?
Sounds good. Thank you so much, Haley. Really appreciate the overview. So first, we're going to go talk about the cryogenic valves. So over to Glenn and Gabe.
Hi there, this is Glenn Guzik from Stennis Space Center. Just to give you a quick overview of what we're looking for, this is for leak-free cryogenic valves and quick disconnects. We're looking for improved sealing performance to eliminate leaks, contamination, and hazards when you're in extreme environments like extreme temperatures, in vibration environments, dynamic loads, dust, and other surface contaminants, corrosion, and other harsh environments for long durations. We want to protect against hazards to personnel, missions, and equipment. So explosive conditions, oxygen depleted conditions, or oxide-rich environments. And you want to prevent flammability concerns. We want to prevent contamination in high clean systems and environmental impacts, such as you might expect in something like the energy industry. So overall, this is to reduce costs for monitoring and other solutions to mitigate leaks. Looking for innovative sealing materials, technologies, and manufacturing methods to improve reliability and efficiency over traditional methods. Gabe, did you want to talk about sort of the in-space approach?
Hi, Gabe. I think you're muted if you're talking.
Oh no, am I up?
Yeah, go ahead.
Mm-hmm.
Okay, so yeah, our topic is the cryogenic valves and disconnects. My focus area is mainly for in space and on surface systems to transfer cryogenic commodities such as liquid nitrogen, liquid oxygen, liquid hydrogen and liquid methane. In space, we're interested in refueling with quick disconnects that have zero leakage, and also for valves that can provide zero leakage for long-term storage in cryogenic fluid management. Our primary goals are zero fugitive emissions and minimal or zero internal leak, lower mass, and single fault tolerant type designs, and compatible with the quick disconnects with robotic or remote operation. For surface systems, it's pretty much similar requirements, except they have to endure the extreme environments and dust. So robotically actuated quick disconnects and valves would be of interest. Also, the consideration for the ConOps of how these systems would be used is something that needs to be considered. On commercial applications, these systems could be applicable to the liquid hydrogen economy that is being developed to generate, store, and transport cryogenic hydrogen. And also currently the liquid natural gas market would be interested in zero leak valves and quick disconnects. That's my introduction to what we're interested in.
Awesome. Thanks so much, Gabe and Glenn. And if you have any questions specifically on this topic, you can feel free to drop any questions into the Q&A function. You can find it on the bottom center of your screen. Okay, and then we're going to move on to the next topic. The next topic that we're going to be talking about is microgravity simulators. And over to you, Sean.
Thank you. And I can't quite see all the distribution. Is Curtis Hill on?
I'm here.
Oh, excellent. Okay. So, yeah, feel free to jump in if you have anything to add. But long and short, one of the major problems that we're seeing with technology development is what we call the valley of death. How do you get from TR4 past that valley of death to actually get to a point where you can actually be infused into a mainline tech demo or mission of some sort. So this topic is looking at how to lower the barrier for technologies to demonstrate in microgravity environments, hence the name microgravity simulators. We can simulate a lot of environments here on Earth, vacuum, thermal, but gravity is a particular tough one, especially where processes come in place, such as growing the semiconductor crystals. And I apologize for my voice; I'm losing it right now. But anything to say to Curtis?
Do you mind if I jump in, Sean?
Yeah, go ahead.
All right. I don't know that my video is going to work. We'll see. Let me know if you guys can see me.
Yeah, we can see you.
All right. I'm here primarily to talk about advanced materials and what microgravity research and development would do for developing in-space manufacturing capabilities for the future. We're particularly focused on semiconducting applications, but what I'm going to talk about is pretty much applicable across a wide range of advanced materials. Currently, for us to do validation or science development, we have to do an orbital demonstration on ISS, or we've got to do suborbital or parabolic flight testing, which are shorter duration, zero gravity or microgravity type events. So what we're looking for is some way of modeling or testing for validation and additional science research into some of these microgravity properties. And just to be a little more specific on it, when we're looking at semiconductor research, for example, we're looking across a wide range of new materials, just as a specific application, maybe to grow crystals for semiconductor wide bandgap materials. And what we may want to do there is evaluate different different types of materials, different alloys of semiconducting materials, and do that in such a way that we can iterate through a large number of experiments and gain applicable data to what we could expect on ISS or zero gravity type research. So what we're looking for in a solution then would be some sort of modeling and or predictive experiments that we could do to model the microgravity the microgravity environment. And there what we see is we have a fairly significant database of information for example, for crystals, and those models could probably be built from that in terms of a starting point. But we're looking for creative and innovative ways to do high throughput experiments on these materials evaluations and different processes that we want to use for semiconductor manufacturing in the future, in preparation for later orbital demonstrations on ISS. So these solutions would integrate, like I said, the existing databases that we have, and so that would be machine learning. We would probably welcome solutions that would take those databases and apply AI across those. We would like to see some in situ or experimental validation of these methods that are being proposed, even if it's only ground-based, to show that the models can be validated. And then any sort of other testing or validation methodology that can be proposed. I think that's kind of a broad statement of what we're looking for, but if you have any questions, just let us know.
Perfect. Thanks so much, Sean and Curtis. And then we'll go to the next topic, lunar surface payloads, and we'll have Ryan Steven talk more about that topic. Over to you, Ryan. Ryan, if you're speaking, you are on mute.
Can you guys hear me here?
Yes, we can hear you now.
Okay, I think I'm on 2 mics. Anyway, so I'm going to talk. Is there an echo with you guys, or is this just me?
No, we are all good. Hearing you
Okay.
loud and clear.
I'll just deal with it. Okay, so my name is Ryan Steffen, and I'm the CLIPS Deputy Project Manager. So CLIPS is NASA's Commercial Lunar Payload Services project, with the overall objective is to develop science, technology, and engineering payloads to the lunar surface to obtain data that would benefit future exploration missions. The secondary goal of CLIPS is to develop a commercial lunar economy, or at least kickstart the commercial lunar economy. Sorry, I'm getting a message on my earphones. So to date, CLIPS has made about 8 awards, and we are manifested to deliver about 50 payloads to the moon, which will have a cumulative mass of several hundred kilograms. But today, we have been the anchor tenant for every single one of these missions. And what we hope to see emerge in the near future is a commercial marketplace where commercial entities have reasons to deliver payloads to the moon. And so some of the specific things we're looking for here are payloads that will allow us to survive the night. So the lunar night is about 14 Earth days long, so it's extremely long, and it's very cold because there's no atmosphere and there's no presence of sun. And so we are looking for technologies that will allow us to survive the night. So these might be insulation technologies or other types of systems to reduce the heat loss over the course of the 14 days. The next one is to operate during the night. And so this is similar in nature, but slightly different in that you want to be able to provide sufficient power so you could actually perform science or engineering operations during those 14 Earth days. The next topic of interest is lunar science instruments to perform studies of the unique environment that's local to the moon. So dust transport, dust levitation, any kind of local magnetic field, seismic activities, space weather, etc. And so those are more science-focused payloads. And then finally, any kind of experiments for lunar engineering. So excavation of the regolith, construction, ISRU, possibly mining operations to obtain resources from the lunar environment. And so those are the 4 basic categories that we're looking for. But I also think that we're open to any kind of interesting commercial payloads that would help us achieve the goal of reducing NASA's position as an anchor tenant on all these missions. So with that, I'll close.
Awesome. Thank you so much, Ryan. Appreciate you giving that overview of kind of what you're interested in and specifically for the lunar surface payloads. Okay, and then moving on to the next topic, last but not least, we will be talking about the radioisotope power systems. And over to you, Erica.
Hi, thank you so much. I'm going to share my screen just to kind of show some notes while I'm talking. Let me know if you can see that.
Yes, that popped up. Excellent.
So what we're interested in is radioisotope power systems with alternative fuel sources. So long duration missions that typically don't have access to the sun for long periods of time require the use of radioisotopes to provide power for the mission. Those types of systems are radioisotope power systems, RPS, have been used for planetary rovers and spacecraft in the past. And they typically use plutonium-238 as their heat source, which has a long life, which is why we need to use that for those long duration missions. RPS systems with an alternative fuel source that may have a shorter half-life, such as americium-241 or other types of fuel sources, are a great opportunity and a great use for lunar applications. The reason is that we could lessen the demand for the plutonium and free that up for other outer planets missions. And we could also have the potential to develop more efficient systems to convert heat to electrical power, which would then decrease the amount of nuclear material needed for any fuel source. Where this ties into commercial is that there's a growing commercial market to develop nuclear microreactors for terrestrial nuclear power generation. And this is identified as a green technology being sought after in the market at this point in time. What we're specifically looking for is proposals that would either develop, test,
Hi, Erica. I think we just lost you there.
Can you guys hear me?
Yes, you are now back on, but we also lost your screen.
That's okay. I'll put that back up. I don't know where you lost me, though. Did you guys hear what I said about commercial?
Yes. We heard the green energy technology in the commercial part, yes.
Okay, great. I'll just start from there. So what we'd like are 2 things. We're looking to develop testing capability for a variety of isotopes or fuel sources. And then we're also looking to demonstrate high efficiency power conversion for alternate isotopes, focused on application for endurance and other lunar survive the night applications. And of course, we're always open to new ideas and new concepts. These are just some ideas to kind of prime the pump and let you know what we see as something that's out there. Thank you so much.
Perfect. Thank you so much, Erica. And that kind of wraps up kind of the NASA SME introductions to the topics. Again, if you have any questions, feel free to pop it into the Q&A so that we can get those answered for you. And I think we already started, some of our SMEs have already started answering some questions in the Q&A. I'm just going to read out some of them just so for folks that can't find the Q&A, you can also see the answers to those. So one question comes from, sorry if I butcher your name, Solange, who asks, Curtis, how much time is needed in microgravity for validation? And then Curtis responded, for parabolic flights, we use 20-second duration parabolas for specific experiments and data. For suborbital, that extends 3 to 4 minutes. Another question was asked by Vanya, who asked, would a COMSOL or ANSYS model of the manufacturing process be within scope? And Curtis said yes, as noted with validation of modeling. For those two questions, Curtis or Sean, anything to add to that before we move on to next questions?
I was trying to get off mute. I apologize. I'm answering another related question on modeling. And I would just say in general in modeling, what we're looking for is something that incorporates the existing databases of information that we have, and we can make those available. But to take that information and take process-specific information that's being modeled and to produce models that can be validated both with ground-based testing and for projected results in a microgravity environment. That's what we'd be looking for.
Awesome. Thanks, Curtis. Okay, let's move on to the next question. This question comes from John Bell. John Bell asks, hi Ryan, is there a website link for the CLIPS Payloads program? For example, we have an interest in dust experiments on the lunar surface. Could NASA potentially fund this? And when will the next round of solicitations for lunar surface payloads be announced? Thanks, John. So I'll take the last part of that question there so far for next round of solicitations in terms of for SBIR Ignite. That will be open in early June, so you can take a look at the solicitation to see which topics are released. But I'll hand it over back to Ryan to answer the rest of the questions there.
Yeah, the short answer is we do have a website that lists all the payloads that have been on the currently awarded manifest. And you can just simply find that by Google and NASA CLIPS. I'm sure it's one of the first links that come up. But we can also send you a link if you'd like. That's the answer to the first question. The answer to the second question, she basically addressed it as it relates to SBIR. But in addition to that, I'll point out that there's a NASA SMD, the Science Mission Directorate. They do a call nominally every year. It's called PRISM. I don't know what it stands for. I'm sure the M's moon and the P is payload. But it's basically a solicitation where we solicit payloads that have specific science goals and objectives. And so you could go research that as well. And like I said, that's nominally an annual thing.
Perfect. Thanks so much, Ryan. Okay, next question comes from James Luck. He says, general question, are going to mandate external investment or customer support memo similar to SBIRs and DoD? I will shoot that question over to Haley.
Thanks. So it is always great to include letters of commitment from external groups that are providing investment. All of the details of that are in the solicitation, and it does help us understand whether or not you, as a firm, are able to bring in investment funds, which is one of the things that we're really looking at with the Ignite pilot. We want to be able to fund firms that are going to be successful taking their product or their technology to market, and understanding that you have the ability to go out and get that investment is really valuable for us to see.
Awesome. Thanks for that, Haley. And also, a new poll was also just launched. Let us know about your experience working with SBIRs and things like that, just so we can get a sense of how we can better help support this community. So please submit that poll that just pops up on your screen. Okay, moving on to the next question. This question comes from Vanya. Vanya asks, question for Ryan, are surface water analysis instruments within scope of this topic?
Could you repeat the question? What I missed the part about analysis.
It says, are surface water analysis instruments within scope of this topic?
Yeah, I think so. I mean, yeah, actually, yes. The answer is yes, they are. I mean, it's obviously that's a valuable resource and one of the primary resources of interest on the moon. So I would think instruments that would have that capability would be of interest.
Awesome. Thanks, Ryan. Okay, next question comes from Henry. Henry asks, on cryogenic valves, how large are the expected vibrations? Shall we need to consider moonquakes that can happen on the moon? So Glenn or Gabe? Or Kevin? Ryan?
So I would say, this is Gabe, the vibration requirement is mostly going to come from launch vibrations. Vibrations on the moon are going to be, minimal compared to launch conditions. So if we have to qualify a flight valve, we would have to put it through environmental dynamics vibration testing. And that would be the most severe case for vibration.
Sounds good. Thanks so much, Gabe. Anything else to add from Glenn or the rest of the team here?
Hey, this is Mark Shoemaker from Stennis. I was just going to follow up on that. Yes, the launch is primary for flight type vibrations at Stennis and other centers with rocket propulsion testing. We have test articles mounted to structure, so the whole system sees a lot of vibrations from just the testing process. So that's where typically you'll see a lot of various leaks form during the testing process, chill down where you got there's slower dynamics, but temperature gradients, shifting, those types of things are all when you typically see the leaks pop up. But the highest vibration is during test article actually running and during launch, as Gabe said.
Perfect. Thank you so much. Okay, next question is from Vanya. Vanya asks Curtis and Sean, are you primarily expecting the incorporation of the Butler database, or is there other data you want incorporated into the models?
Vanya, specifically, I was thinking of the Butler database for crystals. Be aware, too, there's also a Butler database for thin film deposition materials as well. So I would say that either one of those would be acceptable, but that's exactly the sort of input data that I was talking about.
Awesome. Thanks, Curtis. Okay, next question comes from Callan. Callan asks, for radioisotope power systems, would passive thermal management systems that increase the conversion efficiency and system reliability be responsive? Over to you, Erica.
Yes, thank you very much. Yes, that would be responsive. We would certainly be interested in new technology or novel technology on passive thermal management systems. Thank you.
Thanks, Erica. Okay, this comes from Anonymous. Anonymous asks, for lunar surface payload proposals, how would brand new or very small companies plan to fund the launch costs for such a mission? Over to you, Ryan.
Yeah, that's actually a really good question. So that's exactly what we hope to achieve. So, you know, the value, the cost of these missions are, I don't want to get specific, between $100 and $200 million. And today, NASA on these CLIPS task orders, we pay basically the majority, all of those mission costs. The idea here is if we can become a marginal buyer, then you can become a marginal buyer. So it would be unrealistic to expect somebody to have to pick up a $70 million launch vehicle cost to fly a 1 kilogram payload. And so what our vendors typically do is if you have a 1 kilogram payload, they'll charge you something like, they advertise $1 million a kilogram, but I'm sure it's negotiable and it kind of depends on what your demands are. So no, we would never anticipate a small payload would have to pay for the full mission cost, and certainly not the launch vehicle cost.
That's super helpful, Ryan. Thanks so much. Next question comes from Henry. Henry asks, hi, Curtis. How about using direct numerical simulations to provide data that can be fed to machine learning module to predict heat transfer performance?
Okay, would you mind repeating that? I missed the first part of that.
Yeah, no worries. This is from Henry. Henry asks, how about using direct numerical simulations to provide data that can be fed to machine learning module to predict heat transfer performance?
Well, I think it goes back to the same thing I've been saying. That's fine. I think that's good, but the data always needs to be based on our prior history data. I just mentioned a minute ago to Vanya's question, the Butler database on crystal growth or thin film depositions. We just need to make sure that it's consistent with our past results in microgravity, so that it would feed and validate later experiments that we'd be doing in orbit.
Thanks, Curtis. Okay, and then this question comes from Anonymous. What TRL level is generally suggested for this application, or what was the TRL level of the 22 companies selected? I think this is a question for Haley. I'll shoot it over to you.
Hi. So that is a great question. There is not necessarily a suggested level for applications, but historically they've been around 3 to 4 for the ones that are awarded. But that is not a rule, and there are always exceptions to those like common things that we see.
Perfect. Thanks, Haley. And just to follow up with that, if you also want to kind of get a sense of which companies were awarded, you can also see that on the NASA SBIR Ignite website. You'll be able to see kind of the awardees for the last 2 years. Okay, another question comes from Anonymous. This question's for Erica. For RPS, are you interested in alternate isotopes such as tritium and strontium-90?
Yes, thank you. We are interested in alternative isotopes such as tritium and strontium-90. Absolutely, that would be considered some of the alternative fuel sources. We'd want you to, describe why that particular alternative fuel would be of use and how you would utilize some of its advantages and some of the aspects of the particular fuel source that need or challenges that need to be addressed as well. Thank you.
Thank you, Erica. Okay, next question comes from Paul. Paul asks, when is the next call for the CLPS providers going to be? So I'll take a stab at that, but we can also send that back over to Ryan. For specifically NASA SBIR Ignite, we have not yet chosen those topics. The topics will come out when the solicitation is out, and so that's when you would know whether the lunar surface payloads is chosen as a topic for this year. But for generally called for CLPS providers, I'll send that over to Ryan once again.
Yeah, we actually we're going to release the next task order hopefully by COB today. So that we're currently tracking towards that. It's just in a legal review right now. So we should release our next task order today, which will be a polar mission that we would target having the payloads delivered to the moon by the end of calendar year 2027.
Thanks, Ryan. Okay, Paul also has another question. This is for Erica. Are you interested only in thermal systems, or are beta voltaic systems acceptable?
Paul, I'm sorry, I'm not familiar with beta voltaic systems, but certainly if it falls into the call in terms of alternative fuel sources and improved power sources, that would be something that we would consider.
Thank you, Erica. Okay, we are getting towards the end of our session. I don't see any outstanding questions. So if you guys want to put in any last minute questions before we end our last AMA and last session, please make sure to put that in the Q&A. In the meantime, we're going to be launching the ending poll. So before you head out, if you could please fill in kind of, did you learn what you wanted from the session, and how did we do? Please let us know, and please fill it out before you do start heading out. With the remaining time, we'll also be waiting for other questions to come in. But in the meantime, let's also do a brief kind of round robin across the room, just for everyone to give like a sentence of wrapping up, and time for closing thoughts. So maybe I'll shoot it over first to Haley. Haley, you want to kick us off on the wrapping thoughts?
Yeah, thank you so much, everybody, for joining. And thank you for bringing excellent questions and for bringing lots of details about what NASA is interested. So thanks so much to the panelists and to all the firms that joined. Appreciate it.
Awesome. And sorry, let me add one more thing. This is actually a question that we got for one of the topic authors, but maybe we can add this on everyone's wrapping thoughts. So one wrapping thought, and also how can folks continue to connect with you or follow up with you? So for Haley, would you like to connect with folks on LinkedIn, or how would you like to get connected?
Oh, yeah. Donna, if there are more questions about Ignite specifically, you can send those directly to me. I think y'all can drop my email in the chat. If you have questions generally about NASA SBIR, you can reach out to the SBIR help desk. And Donna, if you could drop that one as well. So those are the best ways to get in touch. Thank you.
Awesome. Thank you. Okay, and then let's go next to Erica. Closing thoughts, and how can folks best connect with you?
Sure. This is our first time that we have looked at utilizing SBIR Ignite as a vehicle for RPS development. So I'm really excited. Sorry, can you hear me now?
Yes, we're all good.
Sorry, now my phone is talking to me. Okay, so I was just going to say we're really excited and hope that the community is excited as well. In terms of reaching out and getting in touch with me, you certainly can access me by email, and I'm happy to have my email put in the chat as well.
Awesome. Thanks, Erica. Okay, and then let's go over to Ryan.
Yeah, email is going to be the best way. I don't have any kind of social media presence, so I'm not on LinkedIn.
Sounds good. Okay, and then closing thoughts. That's for the microgravity topic. Let's start first with Sean.
Yeah, I just want to say, yeah, this is also my first SBIR Ignite topic. I'm very excited. Love to see all the participation from the group here. Email's also the best way to reach me.
Awesome. Thanks, Sean.
Yeah.
And then over to Curtis.
I'd like to say that this is actually our second year for what we're doing with advanced materials and semiconductors. We had a topic through our commercialization program, InSpa, last year, and I'd like to say for Ignite that we were very pleasantly surprised both with the quantity of the proposals that we received, but also the quality. For the first year, it was just really impressive. So I think it'll be the same way here. We appreciate everyone joining in, and hopefully, if you have any more questions, you can reach me by email as well, and we'll get any of your questions answered. Thank you for attending.
Perfect. Thanks, Curtis. Okay, and let's go over to Glenn.
Yeah, nothing more to add on the topic, but if you do want to reach me, you can reach me by email, and I'll put my email in the chat.
Awesome. Thanks, Glenn. And Gabe?
Yeah, so this is my first time with the Ignite topic, and looking forward to your proposals. I think you can reach me if you contact. I guess I can put my email as well in the chat.
Okay, perfect. Thank you. And I think we also have Mark on with us as well. Mark, are you still on with us?
Yes, I'm still here. Thanks. Thanks for setting this up, Donna and Haley. Appreciate the time to get our topic information out there. Anybody who's worked with cryogenics knows that leaky valves have been a problem for a long time. We think there's going to be more and more drive to solve those challenges because they create a lot of additional costs. And so as commercial aerospace grows, and alternative energy comes out with LNG and LH, I think we're going to see a lot of push to get rid of those associated costs. And they're definitely not acceptable for space flight and major risks to personnel and missions. So I'm interested to see the proposals and see what small businesses like yourselves can come up with to propose to solve these issues going forward. I can drop my email in the chat. You can contact me anytime. And if you want to go through me, I can get in touch with Glenn or Gabe. They have a lot of duties, a lot of responsibilities within the programs and missions to get these challenges solved. So I'm here to support them, and thanks for the time.
Thanks so much, Mark. Just last call. Am I missing anybody on here? I think we're all good. No additional questions from the Q&A too, so I think we can wrap this up. Refund 5 minutes to everybody's Wednesdays. Again, we will be sending out this recording to all of you here, and watch out for the solicitation that is coming out in early June. If you haven't already, sign up to join our Slack channel. You'll be able to continue discussions and get any updates on there as well. So all of that is in the chat, but really appreciate you taking the time to join us here today, and we look forward to working with you more closely in the future. Thanks, folks, and catch you at the next event. Have a great day.
Thank you.